Hey, what's up, guys? Jung here. So today let's take a look at this classic uh, encoded binary search or recursion with memorization problem, number 50, power xn. So it just simply asks you to implement the power of x to the n, right? Basically, you're given like two integers, if two parameters here. First one is a float, second one is an integer. Ask you to get the what's the result of x to the power of n, right? And so notice that the n could be a negative value here, right? So if it's a negative value, so which means we need to uh, do a one divided by that positive number, right? So with that in mind, we can always convert this number to a positive number and then do the calculation, right? And so for the we want to calculate the uh, the power x to the power of n, right? So how can we quickly approach to the solution, right? So x to the power of 8 equals to what? Equals to the x power of 4 times the x power of 4, right? And then how about 7, right? 7 equals to x power of 3 times x power of 3 times x, right? So so basically every time we can always maybe cut this n to half, right? Based on the if it's a odd number or even numbers, we either do a half and then for the odd number we do a half times the x, and in the end we simply return the recursion result, right? And then how about then what's our base case, right? So the base case is going to be x0 equals to 1, right? x1 equals x. So this is our two base cases. And then we can simply recursively call this helper function. And then also we do a recursion with memorization, right? And this is a by recursion with memorizations, and so that we don't need to repeatedly calculate the same result multiple times. For example, here, right? Basically, we're gonna call this recursion here with number 4 and here also number 4, right? And every time we finish calculating the result for the n here, right? So we'll basically save it into a dictionary so that the next time we try to calculate again with 4, we can simply just return it from the dictionary. All right, cool. So with that being said, let's quickly go to the coding phase here. So we're gonna define the helper functions here. You know what? Let's do basically if n is uh, smaller than 0, we convert it to a negative value, right? And I'm also defining is negative value to false here, right? So that we can use it later on. Is negative value equals to true, right? And then basically we're gonna have like an answer here, right? Equals to the helper n, right? And if is negative, right? And then we do answer equals to 1 divided by answer, right? Simply return the answer here. Okay, now it comes down how we can do a division here. So basically we divide it by 2 here and define helper, right? And with n here. So, and first, if this n, oh, like I said, since we're going to memorize that, right? gonna have a cache in memorizations, right? And then we simply return the memorizations with the current n here. Otherwise, the base case, the two base case, if n equals to 0, we simply return 1. If n equals to 1, we simply return x, right? Otherwise, we do a half and the remainder, right? Equals to div mod current n is 2, right? And this half will be our recursive call here, right? Basically, we do a answer equals to what? Equals to helper half, right? Times same helper equals to half times either x or 1 based on the remainder, right? Times x if if there is a remainder, right? Basically, if the remainder is 1, we times x. Else, if the remainder is 0, we simply multiply 1 here, which means we don't multiply anything, right? And then in the end, we just add this answer to this memorization, right? Return answer. Cool. So I think that's pretty much it is, right? Basically, we just divide it by 2 and then use this, and let's just run it. All right, so this one accepted. Let's try to submit it. Cool. So it's also passed. Yeah. So the only basically two things we need to keep in mind. First is we always convert this n to its positive number, so it's easier to calculate, right? And to calculate n, every time we divide this n into half, right? And then we just need to be careful with these two base cases, right? 0 means 1, 1 means x, and if it's greater than n, we cut them in half, and also this we save the previously calculated results to this memorization dictionary here, right? In the end, we just return it. Okay, yeah, pretty straightforward. I think that's pretty much it is for this problem. Thank you so much for watching the video, guys, and see you guys soon. Bye bye.